Then next theorem is if f from a to b and let f from a to b and if x is subset of b and y is subset of b, x is subset of b and y is subset of b, then inverse image of x union y, inverse image of x union y is equal to inverse image of x union inverse image of y. Similar way to prove of this theorem. Okay, that is here the inverse image of the function, the inverse image of the union of two set, the inverse image of the union of two set is equal to union of their inverse. Okay, union of their inverse image. Okay, the inverse image of the union of two sets is the inverse image of the union of two sets is the union of the inverse image. There means that inverse image of union of two set, this is union of two set and their inverse image of union of two set is equal to union of inverse image, means union of this is union of this inverse image x and inverse image y. Okay, so proof of this theorem. So how to proving this theorem? Similar way to show that f inverse of x, okay, f inverse of x union y is subset of f inverse of x union f inverse of y. And then next to show that f inverse of x, okay, f inverse of x union f inverse of y is subset of f inverse of x union y. Okay, proof of this theorem to show that f inverse of x union y is equal to f inverse of x union f inverse of y. That is to show that f inverse of x union y is subset of f inverse of x union f inverse of y, and f inverse of x union f inverse of y is subset of f inverse of x union y. Okay, so consider let a belongs to, suppose take any element, one element from this set, and to show that this those element is belongs to in this set, let a belongs to f inverse of x union y. Okay, a belongs to f inverse means inverse image of union of two set taking this element, which imply that f of a belongs to x union y. Why f of a belongs to x union y? Why? Because f from a to b and defined function, suppose that here choose taking any elements from x and this is taking any element from y, and then f of x is equal to y. Then inverse function is defined from b to a such that f inverse of y is equal to f inverse of y is equal to x. Okay, so using this definition of inverse, a belongs to inverse image of f, a belongs to inverse image of x union y, which implies that their image f of a is a element of this set a. Okay, inverse image a is belongs to f inverse of x union y means f inverse of x union y means this is belongs to in domain. Okay, f is from a to b, which implies that inverse image is belongs to in a. Okay, so their inverse image is a domain. Therefore A belongs to F inverse X union Y. Then F of A belongs to X union Y, because X and Y is a subset of B, because X is subset of B and Y is subset of B. Therefore F of A belongs to X union Y. F of A belongs to X union Y, which implies that F of A belongs to X or F of A belongs to Y, and which implies that F of A belongs to X or F of A belongs to Y, which implies that A belongs to F inverse of X, means A belongs to inverse image of X, or A belongs to F inverse of Y, means inverse image of Y, and therefore A belongs to F inverse of X or A belongs to F inverse of Y, which implies that A belongs to their union. Okay, their union, and therefore F inverse A belongs to F inverse of X union F inverse of Y, and A is the elements of F inverse of X union Y. Therefore F inverse X union Y is a subset of F inverse of X union F inverse of Y. This is equation number 2. So first equation is conversely to show F inverse of X union F inverse of Y is subset of F inverse of X union Y. Okay, is subset of F inverse X union Y. Let A belongs to F inverse of X union F inverse of Y, taking one element from this set F inverse union of inverse images, then which implies that A belongs to F inverse of X or A belongs to F inverse of Y. A belongs to their union of inverse images, which implies that A belongs to one of the set, this image of this set. Okay, inverse image of this set, which implies that A belongs to F inverse of X or A belongs to F inverse of Y. A belongs to F inverse of X, which implies that F of A, image of A is belongs to in X, or image of A is belongs to this set Y, and which implies that F of A belongs to X union Y. Okay, means union of these two set, image of A is belongs to in union of these two set, and this means that A belongs to F inverse of X union Y. This implies that A belongs to inverse image of X union Y. Therefore A is the element of F inverse of X union Y, and which is belongs to in F inverse of X union Y. Therefore this is a subset of this set. Okay, therefore F inverse of X union F inverse of Y is subset of F inverse of X union Y, and this is equation number 2. Therefore from equation first and second, inverse image of union of two set is equal to union of inverse of images. Okay, union of inverse of images of two set. Okay, this is a proof of inverse image of two set. Inverse image of union of two set is equal to union of inverse images of two set. Okay, so this is one theorem. This is very simple theorem of this chapter. Then next to show that next theorem. Similar way, if F from A to B, and if X is subset of B and Y is subset of B, X is subset of B and Y is subset of B, then intersection of inverse image of intersection of two set, X intersection Y, inverse image of intersection of two set is equal to intersection of their images, F inverse of X intersection Y is equal to F inverse of X intersection F inverse of Y. That is the inverse image of intersection of two set, that is the inverse image, that is the inverse image of intersection of, that is the inverse image of intersection of two set is intersection of intersection of inverse images, inverse intersection of inverse image. Okay, so intersection of inverse images, this is a proof of this theorem, meaning of this theorem. So how to prove this theorem? Similarly we solve this theorem by using this is subset of this set and this is subset of this set. Okay, so proof of this theorem, proof to show f inverse of x intersection y, f inverse of x intersection y is subset of f inverse of x intersection f inverse of y, which implies that is to show f inverse of x intersection y is subset of f inverse of x intersection f inverse of y, and f inverse of x intersection f inverse of y is subset of f inverse of x intersection y. Okay, so how to prove these two subset of each other? Let taking one element from f inverse of x intersection y. Okay, taking any one element from x f inverse image of intersection of two set, which implies that f of a belongs to x intersection y. F of means a belongs to f inverse x intersection y, which implies that f of a means image of a is belongs to x intersection y, which implies that image is belongs to x intersection y, which implies that f of a is must be belongs to x, and f of a belongs to in y. Okay, f of a is belongs to in y. Okay, and therefore f of a belongs to x, which implies that a belongs to their inverse image of x and a belongs to y. Okay, f inverse of y, and therefore a belongs to f inverse of x and a belongs to f inverse of y, which implies that a belongs to their intersection, therefore which implies that a belongs to f inverse of x intersection f inverse of y. Okay, and therefore a is the element of f inverse of x intersection y, and which is belongs to intersection of f inverse of x and f inverse of y. Therefore f inverse of x intersection y is subset of f inverse of x intersection f inverse of y. This is equation number 1. Conversely a belongs to f inverse of x intersection f inverse of y. Then to show that a belongs to f inverse of x intersection y. Okay, which implies that a belongs to f inverse of x and a belongs to f inverse of y. Okay, so a belongs to f inverse of x, which implies that their image belongs to in x, and a belongs to inverse image of y, which implies that image of a is belongs to in y. Okay, means f of a belongs to intersection of x intersection y, f of image of a is belongs to x intersection y, which implies that a belongs to their intersection of union of two set, means x intersection y. Okay, therefore f inverse of x intersection f inverse of y is a subset of f inverse x intersection y, and from 1 and 2 f inverse of x intersection y is equal to f inverse of x intersection f inverse of y. Okay, so this is proof our three theorems. And then for union there is a not true. Okay, so this is seen in next lecture.